Welcome to our new episode of Citizen Science, a podcast from SciStarter. This show spotlights the many different ways that individuals and communities are exploring and changing the world around them through public participation in science. This episode features a conversation between Kyle Copas, Communications Manager at the Global Biodiversity Information Facility, which is known as GBIF, and John Turnbull, the Sydney, Australia Coordinator for Reef Life Survey. The focus of this conversation is citizen science data, how it's collected, what happens to it, and what the process is from collection by citizen scientists to the transformation and processing that brings the data into GBIF's index. Without further ado, here's our conversation with John Turnbull and Kyle Copas.
We're really excited to have John and Kyle here on the podcast, talking about the Reef Life Survey project, GBIF, the Global Biodiversity Information Facility, and all things citizen science data. Could we start with some introductions so we can learn a bit about your backgrounds? John, could you start us off?
Sure. So my name's John Turnbull. I'm the Sydney coordinator for Reef Life Survey. I've been involved in citizen science for 5-6 years now. So I have a background in business and really came into citizen science as a way of pursuing a passion that I had that I'd never really realised through my working career, and have really loved it and found that it's been a great experience, but also a great way to feel like you're making a difference. So I'm very passionate about citizen science and very pleased to be here on the podcast.
Great, thank you. And Kyle?
Yeah, I'm Kyle Copas. I'm Communications Manager at GBIF, which is the Global Biodiversity Information Facility. I am an American, but based in Copenhagen, Denmark, where the Secretariat is housed. My involvement with citizen science really dates back, I guess professionally anyway, to being involved with colleagues. My previous employer, NatureServe, a conservation NGO based outside Washington, where a number of colleagues and I prepared a citizen science strategy that really looked at how they might leverage this emerging trend, probably about 5 or 6 years ago. Since moving to GBIF, I've been taking the lead in terms of engagement with citizen science groups, largely at a regional level. So Citizen Science Association in the U.S., the European Citizen Science Association, and to a lesser extent, the Australian Citizen Science Association. And like John, I would say I'm just delighted to be here.
Well, we're delighted to have you. So John, I want to talk to you first about Reef Life Survey. Is this your first citizen science project, or were there other things you did before you started working with Reef Life?
Well, it's been a bit of a journey to work my way up to Reef Life Survey, really. So when I first decided to volunteer and get involved in marine conservation, I tried a few different projects, and there's often a selection, and there might be ones that are relatively easy. You know, they don't require a lot of skills, and they're a simplified set of tasks. So, for example, you might be diving and you don't record everything you see. You might only record certain species. So I tried those for a while and found that after a little while, I really wanted to do more. You know, if I saw an interesting species that I hadn't seen before, I didn't want to have it excluded on the basis that it was, not on the worksheet. So that's really how I came to Reef Life Survey. And Reef Life Survey, I suppose it's different to a lot of citizen science projects in that it's not a cut down version at all. When you're out there, you're doing a full biodiversity study just like a scientist would be doing. And in fact, you're often diving with scientists, and they're maybe on one side of the tape and you're on the other side, and you're both recording the same data. That was really what attracted me, was the idea that you'd never really stop learning. You're really challenging yourself. You're always seeing new things, finding new things. But really, the other big part of it is you knew that the data that you're collecting was going to be used by scientists and managers to make decisions in the real world. And that was really the attraction of Reef Life Survey.
Talk me through a typical day in the project. What kinds of prep do you do before a dive? Are you looking for specific things at specific times or in specific areas? Basically, how you all make this project happen.
I think the Reef Life Survey people, they're very dedicated scientists in terms of running a high-quality project, and yet they also are really aware of the fact you're a volunteer. So whilst they're keen for you to do as much as you can, it's very much a matter of, well, what are you happy to do and what do you have time for? So there are two ways that we go into the field. We either go and do surveys off our own bat, so you might just say, hey, tomorrow I'm going to go for a dive, dive, and while I'm out there, I'm going to run a survey because I'm on a designated site. And then the other way that we operate is we have intensive periods where a group of people will go to a place and survey that area intensively. So every 2 years, for example, a group of us go to Lord Howe Island and we survey as much as possible in a 2-week period. You just get yourself organised and you find another Reef Life surveyor. Basically, the only equipment that you need to have apart from your scuba gear is a tape that you run out along the bottom, a 50-metre tape, an underwater slate that you can write on with a pre-printed sheet, and a camera to record anything that you need to photograph because it may be an unusual sighting. And then you just basically go and do a dive as you normally would, but you spend most of the time in the water recording all the fish species and so on along the transect tape. And there are very particular methods. So there's method 1 and method 2. So method 1 is where you record all the fish species that you see along the transect tape. And then method 2 is where you're looking more at the bottom, and so you're recording invertebrates like sea stars and sea urchins and so on, and you're also recording cryptic fish species like gobies and things that hide under the ledges. It makes sure that you basically see as much as you can of that 50-metre stretch of reef.
How many volunteers are working on Reef Life Survey?
The program has expanded amazingly, really, when you consider it only started, I think, a bit over 10 years ago now, and it started in Tasmania in southern Australia, and it's exceeded the expectations of the people that started it because it's basically a global program now. So there are volunteers in the Americas and in Asia and in Europe. I think there are a few hundred volunteers. I don't know the exact number. I know locally we have a team of about 10 people that cover the Sydney and Jervis Bay area and also go up to Port Stephens. So, it's not a very large program in terms of thousands of people, but that's because the people that do it are really particularly interested in getting highly involved and they're highly committed. So it's a different style of citizen science program.
You mentioned the kind of data that you collect when you're down there. Can you tell me more about the research questions that scientists and non-scientists explore using this data?
Well, it's an interesting mix of people. So you're often with the scientists. So if we go away for a couple of weeks somewhere, there'll be 1 or 2 scientists as part of that. But you might be diving with, one of my regular dive buddies is someone that works in a telecom company looking after their network. All walks of life, all different types of people, teachers and, engineers and people that work in local government and so on. But they all share a passion for doing something that makes a difference. What you're writing on that sheet of paper is going to go into the global database and is going to be used by scientists. So the data is accessible to the public. You can go online to the Reef Life Survey site. You can download the data. Anyone can go and look at the sites and look at where is this fish been sighted, for example. So it's a publicly available database, but you know that what you're writing down is going to be permanently stored in there. So you're really very careful about being accurate. And then scientists draw upon that massive pool of data. So one of the big problems that we have in science is the big questions that we ask, like what are the effects of climate change, for example, need big data sets. You can't answer what are the global effects of climate change if you're just looking at 3 sites in New South Wales. So this global data set now, which spans 10 years and spans thousands of sites around the world, is now in a position for us to answer those big questions. As an example, one of the big studies that was published a few years ago in Nature was a study that looked at marine protected areas and what are the characteristics of a marine protected area that are necessary for it to work. And that's a really important question, right? If you're going to design a marine protected area, you don't want to design it in a way that doesn't actually have an outcome. So they found that there were 5 attributes of effective marine protected areas. And that sort of answer that globally, these are the 5 things you have to do to make an effective marine protected area, that could only be answered with a data set like Reef Life Survey. If you were to do a study like that without that existing data set, it would take you several years and it would take you, I don't know the amount, but it would be hundreds of thousands of dollars or millions of dollars to gather enough data to answer that question. Whereas now we can answer questions like that with an existing database that is being added to every week by people.
Very, very cool. That seems like a nice segue to turn to Kyle. Kyle, can you give some background on GBIF as well as your role within it?
Yeah, so GBIF is a network and research infrastructure that provides free and open access to biodiversity data, specifically what we refer to as occurrence data. So this is essentially any record from a variety of sources that provides basic information, a name, a scientific name, or at least an identification, a time or date, and a location. If you can say a specific organism was observed or collected at a given time and place, you have the basic substance of an occurrence record in GBIF. What we do as this research infrastructure network funded by the world's governments is aggregate data from lots of different sources, not just citizen science projects, but natural history collections, field survey projects, increasingly other areas, including environmental assessment data. By taking that data, we have some standards that allow us to bring those disparate sources together and really provide a resource base, a knowledge base that represents big data for biodiversity. So John mentioned the need for having large amounts of data, large volumes of data, to be able to answer some of these particularly large-scale, global-scale questions, and GBIF provides a fundamental resource for that kind of work. My role here is formally communications manager, so I'm involved with outreach and speaking to people and describing what we do. But we're a relatively small secretariat. There are 27 of us here, and we work globally across a whole range of different activities. I myself get involved with lots of other things beyond glad-handing people and pushing press releases around, one of them being citizen science engagement. And we knew that this is really an important area, an important contributor to this knowledge base, and I've been involved in trying to understand exactly what that contribution is.
So how does GBIF work specifically with projects like Reef Life Survey and others in the biodiversity realm?
So the way that we work with citizen science projects is, generally speaking, indirectly, because GBIF is a network, formal network. Governments pay for the infrastructure. And what's more, at a national level, there are coordinating points that we refer to generally as nodes, who organize GBIF-related activities in their country. They organize activities within their own network, within their own community, so they tend to be much more directly involved with citizen science projects. Where the GBIF Secretariat becomes more involved is when we're talking about large-scale global projects. And in the case of Reef Life, actually, I came to know one of the founders of Reef Life, Graham Edgar, when he was at NatureServe, the organization that I'd mentioned before. I knew that the work that volunteers like John and the rest of the people in the Reef Life Network were doing structured surveys, repeatable surveys. There was a specific method to what they do, and they often go back and resurvey sites. And they're not just saying, I found something, but I looked for something and I found 5 of them, or I looked for something and I found nothing. Those are all really important in trying to understand research questions, and you can go much further with that kind of data. So as we looked at enriching the data model that we were able to serve through GBIF, Reef Life was an obvious candidate for us to approach. We're grateful that they were willing to join us in at that point, what was a pilot phase in sharing some of their data in this more structured format so that we can make it available along with all of these other sources. I think one of the reasons why it's interesting for the listeners to know about projects like Reef Life, they often know about some of the larger scale projects like eBird or even iNaturalist. We tend to have a lot of bird data globally. Humans are quite good at seeing charismatic things that fly, it turns out. What's interesting about Reef Life is we may be looking at things that are charismatic, but they're harder for us to observe. So to be able to capture the passion that people have for exploring marine environments or other environments, their passion for organisms other than charismatic things that fly, it's really important for scientists and research communities to have data on these other taxa to really understand globally how the biosphere is put together, how the biodiversity communities fit together, and where exactly they are and how they're doing.
In working with citizen science data myself, I'm amazed how people and organizations can make such different kinds of data talk to each other, allowing for it to be used for lots of different purposes. Can you talk a bit about that process of making data work together? How you take that piece of paper that John and his colleagues come back with, how that gets into GBIF, and then how it can be used for these larger biodiversity projects?
So the way that information from projects like Reef Life and others come into GBIF, again, generally through our national coordinating points, GBIF's national nodes. The division of labor can vary, but we'll take the hypothetical example. I don't know the workflow specifically of Reef Life, but it probably goes something like they come back in with their survey sheet and someone records that into a spreadsheet or a database. That then is the source database, and we emphasize the fact that the data that are shared through GBIF really represents an index. It is not a database. It's not someplace that people store the original data. There is a process of transformation and processing that happens to take that source data and get it into GBIF, and it involves standards. These often sort of reduce the disparities between the different kinds of data and allows them then to sort of map certain kinds of information, certain columns of information onto standardized fields. Those are then published or shared into the national network or through other tools into GBIF's near real-time index, where we can run some additional processing, flag things for potential errors, make sure that statements that are made about, latitudes being someplace and a country being someplace, that those sorts of things match. We then can make those available through the primary source of our data at gbif.org.
I'm curious, John, how much you as a volunteer and someone closely involved with Reef Life Survey are familiar with that process of data transformation. What happens to your data after you get out of the water?
We're certainly aware of the importance of the time that we've spent in the water converting into a form that then gets used. So we have a saying, which is we're doing it for the data. That's why you're out there. For example, if you get to the end of a dive and you've lost something, the most tragic thing that you could have lost would be your data sheet. That data is really the whole reason why you're out there. And we enter our own data into a spreadsheet, which then gets uploaded by the Reef Life Survey people. And that process is one where the data is validated. So often you'll get questions back. So they say, this species here, it's unusual to see that on the site. Can you confirm that you saw it? Have you got a photograph? So there's a validation process within Reef Life Survey where certainly in the early days you get a lot of questions back and a lot of, can you show me proof of this? Did you take a photo? And there's also a lot of work that goes into developing your skills. So you do a lot of parallel surveys with others. You check that your sizing is the same as theirs, that you're estimating the same sizes as they are, that you're counting the same number as they are. So there's a whole process within the program of focusing on that data quality. Then you know that it's going into various other databases because the results appear in scientific journal articles. I am often asked by people, can you show me some articles where Reef Life Survey data has been used? I, of course, have my own records of them. And so that's really the whole reason why you're doing it. You see an article published on the effects of range extensions of species due to warming, and you go, that's why I'm out there. So you're very aware of the importance of the data, where it goes. You may not know the mechanics of it, and that's someone else's specialization, but you know that that's the whole reason why you're doing it.
The issue of data quality comes up often in discussions of citizen science, and it's something people in the field need to contend with. Other scientists or researchers not trusting citizen science data because it's not all gathered by professional scientists. How do you respond to that kind of criticism or suspicion?
Can I say a word about that?
Definitely.
Because it is something that we do hear. I think we hear it increasingly less so as others become aware of it. But in fact, these data quality, data validation processes, whether they're training volunteers or reviewing data as they're coming in and vetting them and sharing only those in which the project managers have a great deal of confidence, that's something that happens at every stage in the process of sharing data from, as John so clearly identified, from the volunteers out in the field through the project managers. And then, when data feeds into an infrastructure like GBIF, for us, the role of the national nodes is really important in being able to identify where there may be issues. And so generally speaking, if people are making use of biodiversity data sources like GBIF, and they still feel that, I wouldn't use citizen science data, because it's somehow going to be inferior, they've sort of missed the point that they already are using it. And they're not really recognizing either that there are these processes in place, or that in fact scientific researchers and people who collect data themselves and perhaps don't share it, they have to go through the same things, or there are the same issues with their data. And as you see increasingly mandates from funders, from journal publishers, that researchers need to share their own data, it's all the more important for them to think about data management plans. Likewise, as new citizen science projects crop up, if you are thinking about data, maybe even not at the same level of seriousness that John's talking about being out there for the data, maybe it's a bycatch of your activities. If your intent is to share the data, you do need to think about what the workflows are. It brings in lots of difficult questions around issues, not just standards, but licensing, who owns the data and how do we get permission to share it and use it? And what does it mean to go through these steps and feed it on up into the chain? So the idea that somehow citizen science data is by its very nature inferior is poorly informed at best.
It makes me think of the crowdsourced Zooniverse projects I've worked on, and specifically the animal survey projects. A researcher sets up a bunch of trail cameras and asks volunteers to identify the animals in the sometimes hundreds of thousands of images taken by those cameras. We can't necessarily make all of that data available in the same way, since we don't want people triangulating the positions of vulnerable species for hunting.
Yeah, definitely. This is sort of the challenge of greater openness and greater access to data. We do have to think about those kinds of uses. And in essence, our direction, our guidance from the GBIF network is that if you're uncomfortable sharing data, whether it's because it's sensitive species or there may be, for instance, in the case of researchers, they may actually be keen to publish research based on data before they share it, then don't share it. Share it when you're ready. Share it when you're able. Share it at a resolution that you're able. It's still valuable to many areas of research. It may not be as useful for someone who's looking at a very fine scale local research question around a specific species, but more broadly, there are still uses for data that have this sort of thing attached to it.
Yeah,
Definitely.
and can I add something in there as well? One of the things I did in my corporate life was I worked in quality assurance. And to me, it's understanding that it's about quality assurance of the data more than anything. All data is going to have flaws in it, okay? There are days when the visibility isn't good. There are days when the fish that was on the transect was hidden in such a way that you didn't see it. Doesn't matter whether you're a scientist or not. You just didn't see it. So all data has levels of accuracy. What's important is that you have a process to make sure the data is as high quality as possible. So long as you have those processes where you talk to each other when you get out of the water, what did you see? Let's look at your data. Is your data as close to mine as it should be, given that we're near each other? Every now and then, let's verify that we've got the sizings right. So long as you have a process to ensure your data quality is as high as possible, that's all that anyone can do. I think we have to accept that all scientists, non-scientists, they're all people. They all have their good and bad days, and so nothing is perfect.
Definitely. John, you mentioned a couple of different research projects earlier in our conversation, especially in relation to the health of these ecosystems in a changing climate. Kyle, could you talk about how GBIF data is used in similar kinds of projects and how you track that kind of usage?
Sure. We spend a lot of time looking at research uses of GBIF-mediated data. We have essentially a full-time tracking program, literature tracking program, that increasingly is automated, partly through some improvements that we've made around the process of data citation, using things like digital object identifiers or DOIs, so that people who run, say, a complex search across different species, a specific geography, specific time period, actually can go back and we can identify what data they actually looked at in their research. So this is about creating fair and open data. So not just findable and accessible, but interoperable and reusable. Over the last 2 years, we've had in looking at peer-reviewed uses of GBIF-mediated data at a rate of about 2 scientific uses per day, and actually a grand total of about 4 citations a day. So this is 2 research papers that fundamentally rely on the data that's provided by the GBIF network. And it's not strictly around species conservation, protected areas, these kinds of things. This is one of the sort of emergent properties of big data. You accumulate this data and it becomes a resource for other kinds of research questions that previously people couldn't dive into. So we see not just species conservation and protected areas, but questions about invasive species, questions about climate change impacts, particularly modeling into the future, but things like the connection between biodiversity and human health. Where are the vectors of human disease and where might they be in the future? So, say mosquito-borne illnesses, it may be that changes in the climate will change their distribution and thus put new populations at risk. You can look at things like ecosystem services even and try to understand the value of biodiversity in a financial aspect, or at least in a sort of impact in terms of the services that are provided to human communities and other aspects of life. So right now we serve about 42,000 data sets, Reef Life being one of them. Data from the Reef Life Survey data is downloaded about 450 times a month. So that data feeds into research, again, at a clip of about 2 papers a day. And we increasingly see it across these different areas of scientific research, things that just sort of brush up against patterns of wanting to understand patterns of biodiversity to ask other questions.
That's such a great usage rate, and it exemplifies, I think, what is one of the best things about citizen science, the fact that the data gathered for one project could have benefits for others, even some radically different from the original project.
Exactly. One of the important things is citizen science branches out into other areas of endeavor, other topics, not just, looking at plants and animals and fungi and everything else that we can examine and record. It's a unique instance, a relatively unique instance, in that biodiversity science is further ahead of the curve than many other domains and disciplines. All of this work is basically done on a shoestring budget compared to the amount of money that's invested into other areas of science. GBIF, the Secretariat, and the global operations run on a budget of about 3 million euros a year. And that is peanuts compared to what's invested in cancer research, other areas of health research, large-scale astronomy. And yet we're able to leverage the work that people do as citizen scientists to contribute to the knowledge of biodiversity and the monitoring of biodiversity at a global scale at a level that far surpasses their involvement in any other domain of science.
At this point, I'm sure our listeners, if they're not already involved in a citizen science project, probably want to be. John and Kyle, what kinds of advice would you give people wanting to get involved in these kinds of projects?
From my personal experience, I think it's important that you live out your passions in life. Some people manage to do that through their work, and others do it through volunteering and extracurricular. And to me, citizen science is an opportunity for people to pursue a passion that they have, that they may not be able to pursue as part of their working life, but they can do it on weekends and so on. So I think the first part is that you should pursue that love that you have, and citizen science often is a way to do it, love of the ocean or love of forests or whatever it may be. And it's really a matter of doing a bit of background research of your own. And all these projects are all online, so you can go and look at what's involved and look at what's in your area and find a group of people that you connect with. So you can often attend a day and meet a few people and get a sense for whether they are like-minded people. We often do that with Reef Life Survey. Early starters, they'll say, can I find out more about the program? And I say, come out and have a dive with us and see for yourself. But then ultimately, I think the third part that's really important is you've got to be prepared to make a personal commitment to getting involved enough to make it pay for you and for the program. If you're going to get involved, say, right, I'm going to do it once a month, because everyone's busy. And I think one of the things that really makes a program like Reef Life Survey and others valuable is when people stick with it and get involved. You then get a lot more out of it, and also the program gets a lot more out of your improving skills over time.
Yeah, I really echo that. I mean, John mentioned earlier the notion that one of the things that I think he said in describing his own involvement in Reef Life was that you learn things every day. For me, my background is actually not in science or data. So I use tools like iNaturalist to actually inform myself on what's around me. Having been in the States all of my life and then coming to Copenhagen, I didn't know the flora, the fauna. Definitely not the fungi. This is the land of mushrooms and mosses and snails here in Denmark. So the only way that I could begin to understand that in any sort of personal way was to use these kinds of tools. If you're going to be involved with a citizen science project, you have to, I would echo John's point that it has to follow your passion. It has to be rewarding to you. And there are lots of different ways that can be. For me, I walk the dogs every morning and I'm paying attention to what's along the trail. For other people, it may just be an excuse to get outside and say, well, I'm going to go for a walk, once a day or once a week or 3 times a week. And it provides a sort of pattern of activity. If outdoors is not your thing, there still are ways for you to become involved in citizen science projects, even biodiversity related citizen science projects, through, for instance, the transcription of herbarium specimen labels or natural history collection specimen labels. And those kinds of things are equally important because that also provides another kind of data, unlocks another kind of data for these large-scale questions in just the same way that field observation does.
I hope our listeners will take John and Kyle up on their many suggestions for getting involved with projects that will speak to their own passions. We've just got a couple more questions left, but before we get to those, are there any other questions that you have for each other?
No, it's been fantastic to hear John describing his own involvement in Reef Life Survey. You know, I've known about it for a good number of years, but I think it's the first time that I've heard somebody describe, you know, what drives them to become involved in the project. And obviously working within a research data infrastructure like GBIF, it's really fantastic to hear somebody talk about the importance of data within a citizen science project. Not all projects are like that or need to be like that, but I think it exemplifies one of the reasons for our interest in Reef Life Survey.
Yeah, it's been great to hear your recounting of the use of the data as well. That's massively more than I was aware of, because we're aware of what happens to the Reef Life Survey data that comes out of the Reef Life Survey website, but the fact that it's then syndicated through other processes and ends up in other places is amazing. One thing which I'd be interested in hearing, and I'm not sure what Justin or Kyle, but I think one of the challenges that citizen science faces from the scientist side, often it's this idea of, well, I want to keep control of my project. I want to make sure it's done a certain way. I have a certain method. And often what I'll say to people is, well, if you were prepared to be a little bit more open-minded about the method, so maybe it's a 50-meter transect instead of a 25. Why does it have to be a 25? Then all of a sudden you open this wonderful, huge data store that is otherwise closed to you. To me, it's how do we get the scientific community to be a little bit more open-minded about maybe not data quality, but flexibility with project design. Yeah, that's the way of putting it. Yeah.
Yeah, well, I mean, I think this is increasingly the way that certainly practitioners and people who are deeply involved in trying to understand the practices of citizen science, people like Muki Hackley, University College London, among many others, looking at the different ways that researchers can work together with citizen scientists. It does not have to be limited to data collection. There are questions, research questions, that not only do citizens, lay people have an interest in answering, they may have a very direct impact on their lives, on their health. So people who in a community where air quality is known to be low and who begin to be worried about this may actually want to help design research questions and research projects that start to look at what exactly is going on around a given issue in a given area. This is really how the Flint water crisis became fully understood and at any level began to be addressed. There's still much to do, is by community members who refused to take at face value the denials they were facing around the issues they were clearly seeing with health and water in their community. That can happen on any other number of scales, and it can also be something that people look at in the biodiversity realm too. You're right, John, to point out that researchers should be open and flexible in trying to understand what is it that citizen science can bring to a project. If the project design is really about, monitoring something that's relatively steady state and you're going to rely on people's passions and interests, then perhaps data collection is sufficient. And for many people, it would be sufficient level of involvement. There may be questions about the structure that they're doing, questions about what you're going to do with the data, questions about how exactly it goes forward and where you might try to make use of it, that they could have very valuable insights and input into the design of individual projects.
And I think that turns it then into more of a collaboration and more of a rich experience for all parties, rather than it just being, okay, the volunteers are collecting my data. And certainly there's an egalitarian or a collegiate atmosphere with Reef Life Survey, and that's a big attraction. The fact that, you're going diving with people that are specialists, but they're just part of the group that are up in the research station with you. And so you're all after the same thing, you're all working together. To me, I think there's an opportunity for scientists to engage, whether it's programs or even whether it's just highly knowledgeable members of the public earlier on. An example is a scientist friend of mine's looking at planktivores, so fish that feed on plankton. He was thinking, right, I'm going to have to spend 6 months. I'm going to have to gather all this data. I've got to go and find all this money. But in talking to then the Reef Life Survey people, he realised that he could actually use the Reef Life Survey data set and cut several months off his project and cut tens of thousands potentially of costs of having to pay people to do things. But if he'd gone too far down the track and had gone down the path of a design that then precluded Reef Life Survey, that would have then been missed out. So I think getting in earlier and being open-minded is really important.
Yeah, it's very easy to, at this point, for new startup projects to build an app, right? The challenge is finding the community that supports it, the community of volunteers, finding the time to manage a project, depending on what it is that you want to do. So we try to encourage people to think long and hard about the development of an individual app for a project, especially a small-scale project. Is it really necessary to have a dedicated app to, conduct a survey of fungi in a province in Vietnam? Probably not. There are probably tools that can be extended, translated into a local interface, and then have the whole infrastructure in being able to share data, move data around, make sure that there's an impact to the time that volunteers put into a given project.
And also then you're not worried about structuring that data and making sure that it conforms to these standards so it can be aggregated and interoperable, because those platforms, iNaturalist comes to mind, already has done that work around structuring the data and making it as interoperable as possible. So, don't have to reinvent that wheel.
Yes, indeed.
Well, this has been really, really great. Thank you both for joining us today and for a wonderful conversation. We close each show by asking our guests the same question. What's a project we should have on the show that you want people to know about?
Well, the thing that I want to mention is the continuing role of citizen scientists in monitoring global biodiversity or global monitoring of biodiversity. We know from our most recent sort of look at citizen science contributions to data available through GBIF that while citizen science are responsible for something on the order of about half of the 1 billion records that are available, they actually represent only about 20% of the large groups, genuses that are available in the rest of the other 500 million records. We also know, though, generally speaking, that the data available through GBIF have gaps and biases. Some of these are taxonomic, different kinds of organisms are poorly recorded, but they're also geographic. So what I'm really excited for us to do is now working with our network, our broader network, our formal participants, our national nodes, as well as publishing institutions, data holders in other parts of the world that are not yet formal members of GBIF, to target those areas and those taxa where we really have underrepresented the presence of different types of organisms. So whether it's through targeted expeditions, say, into areas that are poorly sampled that people may be able to access, or to access them using different techniques like sequencing of environmental DNA to identify some of the organisms present in tougher environments to sample. That's something that I think is extremely exciting and something that we will continue to work with citizen scientists on, to not only continue to observe and record and collect information about the natural world in the ways that they already are, but help us understand the areas that we know we don't understand as well. That's really a model, I think, for the future on into the next decade of really becoming much more effective at answering the kinds of questions that we don't yet know the answers to.
Great. And John?
Yeah, look, I think there are so many projects, and I think I'd probably answer your question perhaps in a more general way, and I would say that the human footprint on Earth is now so great that we are confronted by so much bad news. It's easy to get disheartened and throw your hands in the air and say, well, what can I do? I'm really interested in this area of the positive things people can do to actually make a difference. And there are so many positive things you can do, and citizen science is one of them. It's this idea of Earth stewardship, right? I can actually do something that'll make a positive difference, that'll help us understand what's happening in the ocean, that'll help us find an invasive species earlier than we would have otherwise found it. So to me, I think the opportunity is to shift the dialogue from all the negative issues that we have to these are the positive steps that you can take. Citizen science is definitely one of them, but there are many other things, of course, as an active steward of the Earth, the things that we can do as a society to actually take a positive step, grasp the nettle, if you like, and actually do something about improving the Earth's ecosystems. The best project for you to get involved in is the one that's local, that's active, and that is in an area that's your passion. And if you triangulate those, there's probably something that will fit those things for each person.
Well said.
Well said indeed. That sounds like a wonderful note to end on. Again, I want to thank both of you very much for coming onto the podcast today and for talking with us. Hopefully we'll run into you at a conference or probably on a call online or something like that, or maybe sometime I can come down to Sydney and can go on a dive or something like that.
Definitely look me up if you're in Sydney. I'm always up for an excuse to go for a dive.
I'll probably see you on land, John.
Yes, well, I'm actually, part of what I'm doing is interviewing people on land about the positive things they do for the environment. So you might find me on a beach somewhere with a clipboard.
Nice.
Fair
Nice.
enough.
Nice talking to you guys, and great to hear what you're involved in now. It's great to have so much energy behind it.
Likewise.
Well, thank you both for all the work you do.
Whether you're going on a dive with Reef Life Survey or using eBird or iNaturalist on a hike, the data you collect can go into GBIF's global network and index, becoming part of a fair and open data source for researchers. Citizen science data prompts new and exciting research questions. New questions, insight, knowledge, it couldn't happen without you. Citizen Science is hosted and produced by Caroline Nickerson and Justin Schell in conjunction with SciStarter. You can find a transcript of this episode, as well as more information about the podcast at SciStarter.org/podcast. Our podcast should be available on all the major podcatchers: iTunes, Google Play, Stitcher, Overcast, and others. If you can't find it, drop us a line at info@SciStarter.org and we'll get you set up. In the meantime, we'll have a new episode in a couple of weeks. Thanks for listening, and we'll talk to you soon.